Tonight, I want you to imagine something with me. Imagine stepping outside on a calm summer night, gazing up at the stars, feeling the stillness of the universe. You see the familiar constellations, the quiet glow of planets, the steady rhythm of the cosmos as you've always known it. But hidden among those countless pinpricks of light, something new has arrived. Something moving fast. Something that doesn't belong here. On July 1st, a telescope in Chile detected an object unlike any we've ever seen. It was flagged by the Asteroid Terrestrial Impact Last Alert System Atlas. For short, a network of telescopes designed to watch for dangerous rocks that might one day collide with Earth. Atlas's mission is planetary defense. But what it found that night wasn't just another asteroid or comet from the outer reaches of our solar system. It was something much stranger. Something scientists would later name 3 Atlas, the third known interstellar visitor in human history. Oumuamua was the first, discovered in 2017, a strange, cigar-shaped object that baffled astronomers with its unexplained acceleration. In 2019 came Borisov, a more conventional comet, but still alien, born in another star system. And now in 2025 comes a third 3 Atlas. At first, scientists thought it was another comet, a dirty snowball of ice and dust. But the more they looked, the less sense it made. Its speed, its trajectory, its glow, all of it challenged everything we thought we knew about objects drifting between the stars. And that is why tonight's story matters. This is not science fiction. This is happening right now in our own backyard of the cosmos. And the implications are so profound, so unsettling, that some scientists are whispering about possibilities they usually laugh off. So tonight, we will embark on a journey together. For the next 2 hours and 10 minutes, we'll walk step by step through the mystery of 3 Atlas. We'll examine the evidence, weigh the theories, and confront the terrifying question. What if this object isn't just a comet? What if it's something else entirely? When the first observations came in, astronomers immediately noticed something strange. 3 Atlas was moving far too fast to be gravitationally bound to our sun. Most comets we know are like family members of the solar system. They were born here, orbit here, and eventually die here. But this object, it was just passing through. Like a stranger stepping into a room, staying only a moment, and leaving forever. That alone would have been remarkable. But interstellar visitors aren't supposed to be common. Our telescopes scan vast regions of sky night after night, and only 3 times in human history have we spotted one. And yet here was another. Bigger, brighter, and more puzzling than the ones before. At first, astronomers shrugged. Maybe it was just another icy traveler from a distant star system. A piece of cosmic debris that had been wandering the galaxy for millions of years. But then came the second wave of data, and unease began to spread. The light curve, the way its brightness rose and fell, didn't match what they expected. The glow seemed too steep, too sharp, too unusual for reflected sunlight. Some suggested it might be self-luminous, generating its own light, a possibility that would rewrite the rules of astrophysics. But here's where the story takes a darker turn. Because if 3 Atlas is generating its own light, then it might not be as massive as we think. Our standard models assume sunlight bouncing off an object's surface. But if it's shining from within through nuclear decay, thermal emission, or something artificial, then it could be dramatically smaller. Hundreds of meters instead of 20 kilometers. And that difference changes everything. Why? Because the odds of a natural interstellar rock being 20 kilometers across and passing through our solar system are virtually zero. Maybe once every 10,000 years. But a smaller, artificially lit object? That changes the probabilities entirely. Suddenly, what seemed impossible begins to look deliberate. And that's when scientists began whispering the words they usually keep locked away: alien probe. Now, don't misunderstand. The majority of astronomers remain skeptical. They insist this is just a comet, behaving in ways we don't yet fully understand. They point to the dust, the water ice, the outgassing that seems to follow known cometary physics. And they could be right. But skeptics cannot ignore the other facts: the improbably precise trajectory, the perfect alignment with planetary orbits, the hidden perihelion passage where Earth cannot observe. Coincidence or calculation? Harvard astrophysicist Avi Loeb, famous for suggesting Oumuamua might be alien technology, has co-authored a provocative new paper. His argument? That 3 Atlas may be another probe, a disguised spacecraft from another civilization sent to study how humans react. If that sounds outrageous, remember, science is not about comfort. It's about confronting evidence, no matter how unsettling. And the evidence is piling up. This is why scientists fear what 3 Atlas really is. Not because they're convinced it's alien, but because they can no longer dismiss the possibility. But that's not the only fear. There's another quieter dread whispering at the edges of this mystery. What if 3I Atlas isn't a probe, but a carrier? What if, buried within its icy core, it holds something alive? Microbes, frozen in alien ice, carried across interstellar space for millions or even billions of years. The panspermia hypothesis, the idea that life can spread from star system to star system on the backs of comets, has long been debated. And 3I Atlas could be the first real test. Imagine if alien microbes are locked inside. What would happen if they were released? Onto Mars as the object passes close? Onto Earth as dust and ice scatter through our atmosphere? Would they be harmless? Would they die instantly? Or would they awaken, ready to thrive in a new world? For scientists, this isn't just speculation. It's a real planetary protection concern. Because if alien biology touches ours, the results could be unpredictable, irreversible, and catastrophic. That's the second reason 3 Atlas terrifies scientists. Because even if it's just a comet, it might carry something more dangerous than technology. It might carry life. And so here we are, standing at the edge of a mystery with no easy answers. Over the next chapters, we will explore both possibilities, the probe and the microbe, the spacecraft and the comet. We will dive into the numbers, the probabilities, the physics, and the philosophy. We will see how scientists wrestle with evidence that defies their expectations, and how humanity grapples with the possibility that we are not alone. This is not a comfortable journey. It is not meant to be, but it is necessary. Because whether 3 Atlas is natural or artificial, harmless or dangerous, its arrival is a reminder that the universe is far stranger than we know. So settle in, turn down the lights, and let your imagination stretch beyond the safety of Earth. Because tonight we are going to ask the questions that scare us most. What if 3 Atlas is not a comet but an alien probe? What if 3 Atlas carried alien microbes? And most of all, what if the truth is even stranger than that? When scientists first pointed their instruments at 3 Atlas, they expected to see the same familiar patterns they had observed in comets for decades. Comets are simple creatures in the grand story of astronomy, icy remnants of formation, drifting relics from the outer solar system. As they approach the sun, their frozen surfaces heat up. Water ice sublimates into vapor, carbon compounds erupt in gas jets, and dust scatters into space, forming the iconic coma and tail. Their brightness, their light curve, follows rules so well understood that astronomers can predict them years in advance. But from the very beginning, 3 Atlas refused to obey. The first observations from the Hubble Space Telescope revealed something that made even seasoned astronomers shift uncomfortably in their chairs. The object's brightness did not rise in the expected smooth arc. Instead, it spiked. Its light profile grew steeper, sharper, more concentrated. At first, researchers thought it was an error in calibration, a trick of the instrument. But then other telescopes, from Gemini South in Chile to the NASA Infrared Telescope Facility in Hawaii, confirmed the same thing. This wasn't a mistake. This was reality. The glow of 3 Atlas was simply too strange. Let's take a moment to understand what brightness means in astronomy. When light from a distant object reaches us, we measure its intensity, the apparent magnitude. From this, combined with its distance, we can calculate how large and reflective it must be. It's like judging the size of a candle from how brightly it glows across a room. The mathematics is straightforward if the candle seems brighter than expected. Either it is bigger or it is producing more light of its own. For 3 Atlas, the numbers didn't line up. If it were only reflecting sunlight like a normal comet, it would need to be colossal, perhaps 20 kilometers in diameter. To put that in perspective, that's the size of Mount Everest, drifting as an icy rock between the stars. But here's the problem. The statistical probability of a natural interstellar body that large wandering into our solar system is vanishingly small. The galactic reservoir of rogue asteroids simply doesn't contain enough giants. By most models, a visitor of that size should appear once every 10,000 years or more. And yet here it was, right in front of us, glowing in our skies in 2025. Unless, of course, it wasn't reflecting at all. Unless it was shining from within. That possibility rattled the community. Some proposed exotic natural explanations. Perhaps 3 Atlas contained radioactive isotopes that glowed as they decayed. But that would require vast quantities of unstable elements, more than we have ever observed in comets. Others wondered if unusual chemistry on the surface could trap and re-emit sunlight in unexpected ways, like phosphorescent minerals glowing after exposure. But again, the numbers didn't add up. To produce the brightness observed, 3 would need to generate on the order of 10 gigawatts of power. That's the energy output of several nuclear power plants combined. Not for minutes, not for hours, but sustained over potentially millions of years as it wandered between the stars. For a natural body, such a feat seemed impossible. And that is when the most controversial theory resurfaced. Harvard astrophysicist Avi Loeb, who had already gained notoriety for suggesting that Oumuamua, the first interstellar visitor detected in 2017, might have been alien technology, stepped forward again. Together with colleague Eric Quito, he published a provocative paper. Perhaps 3 was not a comet at all. Perhaps it was artificial. The brightness, they argued, could be artificial illumination technology. A probe disguised as a natural rock, powered by its own internal energy source. It was a hypothesis so bold, so unsettling, that many scientists dismissed it outright. But even those who laughed nervously couldn't explain away the data. The steepness of the light curve remained. The size paradox remained. The improbable brightness profile remained. And suddenly, the scientific community was once again thrust into the uncomfortable space between skepticism and wonder. Think about what this means. For decades, the search for extraterrestrial intelligence SETI has focused on listening for signals, scanning the sky for radio transmissions from distant civilizations. We assumed aliens would communicate like we do, broadcasting across the stars. But what if they don't send signals at all? What if they send probes, machines drifting quietly between star systems, designed to look like natural objects until anomalies reveal their true nature? 3, with its suspicious glow and improbable statistics, might be one of those probes. If that's true, then the implications are staggering. It would mean that another civilization not only exists, but has mastered interstellar travel. It would mean we are being observed, tested, maybe even studied without our consent. And it would mean humanity's dream of being the only intelligent species in the cosmos is just that, a dream. But while the probe hypothesis excites imaginations, another possibility has begun to haunt scientists in quieter tones. What if the glow isn't technological at all, but biological? Consider this: life on Earth has evolved bioluminescence countless times. Deep-sea creatures glow in the dark abyss. Fireflies light up warm summer nights. Even fungi emit faint luminescence on rotting wood. If nature has found ways to produce light on Earth, why not elsewhere? Some researchers speculate that microbes frozen in the ice of 3 could be releasing faint light as they thaw. Their metabolism, alien and unknown, could glow as a survival mechanism. Imagine microscopic organisms locked in ice for billions of years, carried across interstellar space, suddenly warming as they near our sun and shining faintly as they awaken. It sounds like science fiction, and maybe it is. But it cannot be ruled out entirely. And that possibility that 3I Atlas is not only a rock, but a carrier of alien life, is perhaps even more terrifying than the probe hypothesis. This is the double edge of the brightness puzzle. If it is natural, then physics itself is incomplete. We must accept that there are processes we do not understand, chemistry we have not seen, phenomena we cannot yet explain. That alone would be unsettling, a reminder of how much we don't know. If it is artificial, then we are not alone. Another intelligence has crossed interstellar space and left its signature in our skies. That would be the most important discovery in human history, rewriting our understanding of life, of civilization, of our place in the cosmos. And if it is biological, if it carries microbes, glowing or otherwise, then the implications shift from wonder to dread. Because microbes don't need to be intelligent to change a planet. They only need to survive. Meanwhile, the data keeps coming. The James Webb Space Telescope has already trained its infrared eyes on 3 searching for heat signatures that might reveal whether the light is reflected or generated. Ground-based observatories continue to track its brightness, plotting every flicker, every curve. And yet, clarity remains elusive. The glow is still too steep. The numbers are still too improbable. And so the debate rages on. Is this a comet, a probe, a carrier of life? Each answer carries its own kind of terror. Each challenges us in ways we are not prepared for. But one fact is, undeniable brightness is not just a number. It is a story. It is the fingerprint of whatever 3 truly is. And right now, that fingerprint doesn't match anything we know. In the next chapter, we will confront the boldest possibility directly. What if 3 Atlas is not a comet at all, but an alien probe? And if so, what does that mean for humanity standing on the fragile shores of its tiny world, suddenly aware that it might be under observation from the dark? For centuries, humanity has looked at the night sky and wondered whether we are alone. Every star is a sun. Many suns have planets. And surely on some of those countless worlds, life must have arisen. Yet despite all our searching, despite decades of listening for signals, we have found nothing. Silence. And then suddenly an interstellar visitor appears first, Oumuamua in 2017, then 2 in 2019, and now in 2025, the brightest, strangest of them all, 3I Atlas. From the moment it was detected, scientists knew this was not just another rock. Its trajectory was too perfect, its brightness too steep, its alignments with planetary orbits too improbable. And soon whispers began to spread through the scientific community. What if this is not natural? What if it's a machine? Imagine the design of such a machine. If an advanced civilization wanted to explore other star systems, the distances are so vast that traditional spacecraft, like the ones we launch, would be far too slow. Alpha Centauri, our nearest star, is more than 4 light-years away. With today's rockets, the journey would take tens of thousands of years. No civilization builds ships for voyages that long unless they are unmanned probes. An alien probe would not need to be large. It would not need to carry passengers. Instead, it would need to be durable, self-sustaining, and capable of disguising itself. And what better disguise than the appearance of a comet? Comets are common. They attract little suspicion. They are icy, dusty, and unpredictable. If you wanted to hide in plain sight, drifting across the skies of a foreign world, you could not ask for a better camouflage. 3ATLS, glowing in ways we cannot explain, traveling in ways that defy probability, fits that description all too well. Let us consider its trajectory. The numbers are chilling. This object is moving on a retrograde orbit, tilted only 5 degrees from the ecliptic. Plane the very plane where Earth and most planets revolve around the sun. The odds of this happening by chance? Roughly 1 in 500. But then we look closer. 3 Atlas will pass close to Mars, closer than almost any interstellar object has before. Weeks later, it will swing by Jupiter, again improbably close. And its path is so finely tuned that it reaches its closest approach to the sun when Earth is hidden behind our star, unable to observe it directly. If this were a spacecraft designed to maneuver stealthily through the solar system, the trajectory could not be more perfect. A retrograde orbit for flexibility, close planetary passes for gravity assists or observations, a perihelion hidden from Earth's telescopes, allowing secret operations beyond our view. Coincidence, perhaps, but how many coincidences add up to design? And then there is the light. If 3 Atlas truly generates its own glow, then it is not only artificial, it is deliberate. Light in space is communication. Light attracts attention. Light reveals presence. If an alien probe wanted to test humanity's response, there is no better way than to shine just brightly enough to be noticed, yet strangely enough to inspire debate. Are we being tested right now? This idea terrifies scientists because it shifts the narrative from cosmic wonder to surveillance. We are used to thinking of ourselves as explorers, as the ones reaching outward. But what if we are the ones being observed? What if 3I Atlas is not a random traveler, but a probe placed here intentionally to watch us? Consider the concept of the galactic zoo hypothesis. Some researchers suggest that advanced civilizations avoid direct contact with emerging species, instead choosing to watch from a distance, like zookeepers observing animals through glass. If that is true, then perhaps 3 Atlas is one of their instruments, an automated sentinel, cataloging our behavior, monitoring our progress, waiting for the moment we are ready, or worse, waiting for the moment we are dangerous. The fear grows when we consider the possibility of technology hidden beneath its icy shell. If this is a machine, what powers it? Nuclear decay, fusion, something beyond our physics? A device that can cross interstellar space must possess an energy source vastly superior to our own. The thought alone is unsettling. And what if it carries more than instruments? What if it carries instructions? What if it carries a message, a signal waiting to be unlocked by a species intelligent enough to recognize it? Or what if it carries something far darker? History reminds us that contact between civilizations is rarely gentle. When explorers from advanced empires encountered isolated tribes on Earth, The result was often exploitation, conquest, or collapse. To us, those stories are history. To an alien civilization, they may be strategies. If 3 Atlas is a probe, then humanity stands in the same position as those tribes watched, measured, and vulnerable. Yet there is another perspective. What if it is not here to harm us, but to help? Imagine a civilization older than ours by millions of years, watching young species like gardeners tending a fragile ecosystem. A probe like 3 Atlas could be a gift, a silent messenger carrying knowledge of medicine, energy, or survival. Perhaps it drifts from system to system, leaving seeds of wisdom for those who are curious enough to study it. If that is true, then dismissing it as just a comet could be the greatest mistake in human history. The truth is, we do not know. And that uncertainty is what terrifies scientists the most, because every possible answer carries enormous consequences. If it is a natural comet, then our physics may be incomplete. If it is a probe, then we are not alone, and we are being watched. If it is something in between, part natural, part artificial, then we face a reality more complex than we ever imagined. In October, when 3 Atlas passes Mars, we may have our first chance to find out. The Mars Reconnaissance Orbiter could capture images of its surface. If those images reveal smooth metallic panels instead of dusty ice, then everything changes. Imagine the announcement: we have photographed an alien spacecraft. Humanity would never be the same. But let's ask one final question: if this really is a probe, why now? Why in 2025? Why during the brief century in which humanity has finally built the tools to notice it? The answer may be simple: because this is the moment we are ready. Ready to observe, ready to wonder, ready to decide what kind of species we will be when the universe finally says hello. And so, as 3 Atlas blazes across our skies, we are left with a haunting question: is this a comet or a calling card? When people hear the word alien, they often imagine green-skinned beings, advanced spaceships, and civilizations stretching across the stars. But in reality, the first form of alien life we may ever encounter is far more humble and far more dangerous. Not intelligent beings, not advanced technology, but microbes. Tiny organisms, invisible to the naked eye, yet powerful enough to alter the course of life on Earth. So let us ask the question: what if 3 Atlas is not merely a rock, not a probe, but a carrier? What if, locked beneath its icy surface, are living alien microbes, seeds of life from another star system, drifting through the void, waiting for a place to awaken? The idea of alien life has always stirred both wonder and fear in the human imagination. We picture towering beings, spacecraft with gleaming hulls, and civilizations communicating across the stars. Yet scientists know that the first encounter with alien life is unlikely to be so grand. It may come not as a fleet, but as something microscopic, invisible to the eye, fragile and yet unimaginably powerful. The greatest shift in human history may not come from a signal in the sky or a spacecraft on the horizon, but from microbes frozen in the heart of a wandering object from another star. And so we ask, what if 3 Atlas, the mysterious interstellar visitor speeding through our solar system, is not a simple comet, not a rock or an artificial probe, but a carrier? What if it holds within it the seeds of alien life, locked in ice, waiting for the right world on which to awaken? Microbes are the survivors of the universe. On Earth, they thrive in boiling vents at the bottom of the ocean, in the frozen wastelands of Antarctica, in radioactive pools that would kill larger animals instantly. Some bacteria can turn into spores, sealing themselves away to endure centuries without water or heat. Tardigrades, those strange, resilient creatures, no bigger than grains of sand, can survive the vacuum of space, the intensity of cosmic rays, and the freezing cold between planets. If life on Earth can adapt so perfectly, then life elsewhere could too. And if such life can survive, it could hitch rides on rocks, comets, and fragments of shattered worlds. It could cross gulfs of interstellar space. It could be delivered across the cosmos. This is the idea of panspermia, the theory that life is spread from star to star, not by ships or deliberate design, but by the patient, blind journeys of microbes clinging to stone and ice. 3 Atlas, with its water ice signatures, pristine chemistry, and interstellar trajectory, is a candidate too perfect to ignore. The spectroscopic evidence tells us its ice is unusually clean, lacking the isotopic fingerprints common to comets born within our solar system. That suggests it has never been close to a star like ours before. It has drifted in the dark for billions of years, carrying its frozen cargo across unimaginable distances. If microbes exist within it, they could have been preserved since the birth of another star system. They could have formed in alien oceans, frozen in subterranean caves, carried upward in planetary collisions, and entombed in ice before being launched into the void. And now, by chance or by design, they are passing through our neighborhood. The danger and the wonder lie in the same fact. If those microbes are alive, even in dormant form, then humanity may be on the edge of discovering that life is not unique to Earth. The implications would be staggering. Religion, philosophy, and science would collide. We would no longer ask whether life exists elsewhere, but how common it truly is. And if it is common, then intelligence too may be common. We might not be alone in the galaxy. We might never have been. Yet the risk is just as profound. For if alien microbes can survive here, then Earth's biosphere is vulnerable. History reminds us that when two isolated ecosystems meet, devastation often follows. The Black Death swept across continents, killing half of Europe. Smallpox erased civilizations in the Americas. Even the common cold can decimate populations with no immunity. And those were merely encounters between human societies. What then would happen if Earth's organisms met microbes born beneath another star? With metabolisms built on unfamiliar chemistry, against which we have no defense, a single alien bacterium might be harmless, or it might be catastrophic. Planetary protection protocols already warn against such dangers. When spacecraft return samples from Mars, they are quarantined in high-security labs. Astronauts returning from the moon were once kept in isolation for weeks, even though lunar life was unlikely. Because the fear is simple contamination. It can work both ways. We could infect them, or they could infect us. If 3 Atlas carries life, the risk of contact may be greater than the promise of discovery. But suppose contamination is not the end of the story. Suppose the microbes on 3 Atlas are not accidental at all. Some scientists and philosophers entertain a darker or more wondrous possibility that panspermia is not random, but directed. That advanced civilizations may deliberately seed the galaxy with life, sending microbes frozen in comets toward worlds that might sustain them. Perhaps Earth itself was seeded this way. Perhaps all life we know began with a visitor from the stars. If so, then 3I Atlas is not just a comet. It is a messenger, a sign that we are part of a far greater biological network stretching across the Milky Way. Now imagine the implications of deliberate design. If an advanced intelligence sent this object, then microbes might not just be biological hitchhikers. They might be engineered, designed to awaken under specific conditions, to survive planetary atmospheres, to replicate, or even to signal their presence. They might carry molecular patterns that could encode information. They might be gifts or warnings. They might be tools of exploration, tiny probes testing the biosphere of any planet they touch. Some scientists resist such speculation. They point to natural chemistry. They note that comets regularly carry amino acids, carbon chains, and other building blocks of life. The famous meteorite ALH-84001 from Mars contains structures that some claim were fossilized bacteria, though the evidence remains disputed. Life's ingredients are everywhere. That does not mean life itself exists everywhere. But the question refuses to die. If it is possible, then someday, somewhere, it must happen. And 3I Atlas is the best candidate we have ever seen for such an experiment. As it nears the sun, 3 Atlas will release its gases. The heat will vaporize its ice, carrying dust and any trapped particles into space. If microbes are within it, they may be released into the void. Some may drift aimlessly. Some may burn in sunlight. Some may fall toward planets. Mars, with its thin atmosphere, may be the first testing ground. If alien organisms fall onto its soil, future missions may find not just Martian life, but something older, stranger, seeded by this interstellar traveler. Earth, too, may not be safe. Though the chances are small, dust from its tail could one day drift toward our atmosphere. We may already be breathing the remnants of another world. The thought is exhilarating and terrifying. Would we recognize alien microbes if we saw them? Our microscopes could detect their shapes, but would we even know what we were looking at? Their biochemistry might not use DNA. They might build proteins with amino acids unknown to us. They might metabolize using pathways alien to our understanding. They might not even register as life until they grew, spread, and revealed their effects. And by then, it might be too late. There is also the possibility that they are harmless, unable to thrive here. Our oxygen-rich atmosphere, our competing microbes, Our ultraviolet light might kill them instantly. They could die silently, never leaving a trace. And yet even then, the discovery would be monumental, because it would prove we are not alone. It would prove that biology is not unique to Earth, but a property of the universe itself. The months ahead will be critical. As 3I Atlas nears perihelion, astronomers will watch for signs of unusual chemistry. The James Webb Space Telescope will scan for organic molecules in its outgassing. Mars orbiters may catch glimpses of its surface, revealing features that hint at biological activity. Ground-based telescopes will search for patterns in its tail, hoping to distinguish mere dust from something stranger. Every data point matters, because the difference between a natural comet and a carrier of alien life could lie in a faint spectral line, a subtle anomaly, a trace of chemistry that does not belong. And what of humanity's response? If evidence arises that 3 Atlas carries life, how will we react? Some will demand strict isolation, fearing contamination. Others will clamor for bold exploration, eager to capture samples, to hold alien life in our hands. Governments may argue over secrecy or openness. Religions may see proof of creation or of universal design. Philosophers will debate whether such life is kin or stranger, whether we share destiny or face competition. The world will divide, as it always does, between fear and curiosity. But perhaps the greatest danger lies not in microbes themselves, but in our imagination. Because if we believe 3I Atlas carries life, even without proof, the story may take on a power of its own. Conspiracy theories will spread. People will say governments are hiding infections. They will point to unexplained illnesses, to strange weather, to anything they can imagine and connect it to the comet. Fear may spread faster than any microbe. And once fear takes root, it is almost impossible to control. Yet even in that fear lies wonder. For if 3I Atlas does carry alien microbes, then we are no longer alone. Life is not Earth's secret. It is the universe's gift. And in that realization lies a profound truth that biology is not bound by planets, but by stars. That every world may be a potential garden. That existence itself may be seeded across the cosmos, waiting to bloom wherever conditions allow. As 3 Atlas races past Mars and toward the sun, we wait. We wait to see what its ice will reveal. We wait to see whether its dust carries mere chemistry or something more. We wait to learn whether this visitor is just another comet or the first carrier of alien life we have ever known. And in that waiting, humanity finds itself at the edge of its oldest question. Not just whether we are alone, but whether life itself is a universal law, flowing between stars, carried on frozen arcs across the endless sea of space. Because if 3I Atlas carries microbes, then we are not the beginning. We are part of a chain. We are one chapter in a story that began long before Earth and will continue long after. The night sky has always deceived us with its beauty. We look at the stars and think we are seeing the present, but we are not. Every gleam is delayed, every photon a messenger from the past. When astronomers turned their instruments toward 3I Atlas, they expected the same old trick: sunlight, bouncing off a fragment of ice and dust, reflected back across the void. That is the assumption behind centuries of astronomy. What shines in the darkness is simply light borrowed from our star. But with 3 Atlas, that assumption began to fracture. The glow did not behave like the glow of a comet. It was too steep, too steady, too strange. And in that strangeness, scientists found themselves facing a question more unsettling than any they had dared to put into words. What if this object was not reflecting the sun at all? What if it was shining by itself? In the ordinary model, comets are predictable creatures. They begin as icy remnants stored in the deep freeze of the Oort cloud or beyond. As they wander inward toward the sun, heat awakens them. Water vapor and carbon monoxide erupt from beneath their crust, carrying dust into space. The dust forms a cloud, the cloud catches sunlight, and the comet glows. Its brightness follows simple rules. The closer it comes to the sun, the brighter it gets. The further away, the dimmer it becomes. But 3I Atlas refused to follow these rules. The measurements showed a glow far more intense than its distance justified. Its brightness curve was steep, its persistence unnatural. To fit the data under the old model, the object would have to be enormous, perhaps 20 kilometers across, a behemoth of interstellar ice. But other evidence suggested it was much smaller. The contradiction was unavoidable. Either this was the largest interstellar comet humanity had ever seen, or it was something else entirely. Astronomers are trained to resist extraordinary conclusions. The first explanations leaned on nature. Perhaps radioactive elements buried within the ice were breaking down, releasing energy that glowed faintly in the dark. But the amount required would be immense, the kind of power we associate with nuclear plants, not wandering comets. Perhaps the object was still hot from some primordial birth, bleeding out thermal radiation as it coasted between the stars. But again, the mathematics strained credibility. An object adrift for billions of years cannot stay warm enough to shine. Others suggested exotic ices, chemicals that sublimate in unusual ways. Hydrogen cyanide, carbon monoxide, even frozen methane. But none of them fit the curve. None of them explain why the brightness seems so steady, so deliberate. One by one, the natural theories bent under the weight of the evidence. And when natural explanations fail, the imagination begins to wander. The alien hypothesis whispers at the edge of the data. What if 3 Atlas is not a comet at all, but a machine? What if the light is not borrowed, but generated like a lamp shining in the void? The idea is not as wild as it seems. Humanity has sent its own glowing machines into the dark Voyager, New Horizons. Spacecraft with power sources that emit steady radiation. If we can do it, why not others? Some scientists imagine a probe using light as camouflage, pretending to be a comet but shining too consistently to truly pass as natural. Others imagine propulsion, a drive that releases energy in visible bands as it slows or steers. Others still see the glow as a signal, a beacon meant not for us, but for some unseen recipient across the stars. If that is true, then 3 Atlas is not just a visitor. It is a message. The probability argument only deepens the unease. Finding an interstellar comet 20 kilometers wide is nearly impossible. The galaxy does not scatter such giants into space often. One calculation suggests such an object should pass through our solar system only once in 10,000 years, if that. Yet here it is in 2025, appearing just decades after the smaller Oumuamua and Borisov. The odds do not fit. A smaller, self-luminous object, however, is far more plausible. And so the alien explanation, paradoxically, may be more probable than the natural one. This inversion of expectation has left even skeptical scientists uneasy. For once, the simplest answer may not be natural at all. But how does one prove such a claim? Light is deceptive. A flare can be chemistry. A curve can be coincidence. And extraordinary claims require extraordinary evidence. Astronomers debate fiercely. Some insist on sticking with the natural model, however strained. They point to comets with unusual behaviors in the past, outbursts and flares we did not understand but later explain. They remind us that nature is stranger than we think, and that rushing to invoke aliens is a mistake. Others point to the growing pile of coincidences, the brightness too steep, the trajectory too precise, the timing of its concealment behind the sun too perfect. At some point, coincidence looks like design. And when the universe starts looking like design, we are forced to ask harder questions. What would it mean if 3 Atlas were artificial? The implications ripple outward like shockwaves. It would mean we are not the only builders of machines. It would mean we are not the only intelligence in the galaxy. It would mean that the dark is not empty. Humanity would no longer stand alone on its island of rock. We would be observed, perhaps tested, perhaps ignored, but not alone. The glow of 3 Atlas would become the first undeniable evidence that we are part of a larger story, one stretching beyond our world, beyond our star. For some, the idea is exhilarating. For others, it is terrifying. But no one can look at such a possibility without feeling the ground shift beneath them. The months ahead will be crucial. As 3 Atlas sweeps closer to the sun, its glow will be measured again and again. The James Webb Space Telescope will examine its infrared spectrum, searching for signs of heat inconsistent with simple reflection. The Mars Reconnaissance Orbiter may catch glimpses during its close approach to the red planet. Ground-based observatories will record its light curves nightly, hoping to catch a deviation, a moment when the brightness defies all natural models. And radio telescopes will listen, straining for any hint of a pattern in the silence. Because if the light is artificial, there may be more to hear than to see. Public imagination is already ahead of the science. Headlines speak of alien probes, of hidden spacecraft, of messengers in disguise. Social media hums with speculation. Some believe it is a harbinger of doom, others a sign of hope. Some imagine invasion, others imagine salvation. The truth may be none of these. The truth may be far simpler or far stranger. But one thing is certain: humanity has already been changed by the question. For the first time, millions of people are asking not whether life exists elsewhere, but whether it has already reached us. The beauty of this mystery is that it forces us to look inward as much as outward. What do we expect from the universe? Do we assume it is empty, cold and silent, and thus dismiss every anomaly as coincidence? Or do we allow ourselves to consider that intelligence may be as natural as stars, scattered across the galaxy, each civilization, sending out its messengers? Our reaction says as much about us as it does about 3 Atlas. Perhaps the real revelation is not whether this object is artificial, but whether we are ready to accept that possibility. For now, the glow continues. It shines steadily, a point of light racing across the heavens. Too bright, too strange, too stubborn to be ignored. We may not yet know its true nature, but we cannot look away. And in that act of watching, in that act of wondering, we are already changed. Because whether natural or artificial, 3i Atlas reminds us that the universe is larger, stranger, and more alive than we ever imagined. It reminds us that light itself can lie, and that behind every gleam may be a truth we have not yet dared to face. When the records of this century are written, perhaps this will be the moment they mark. Not the wars or the politics, but the time humanity first questioned the glow of an interstellar traveler. The time we wondered aloud whether the light in the sky was not the sun's, but its own. The time we realized that the greatest mysteries do not come with answers, but with questions so vast, they remake the way we see everything. And as 3 Atlas continues its journey, as it burns or shines or deceives, one truth will endure. That we looked up, saw the light, and dared to ask, why does it shine? Mars has always been a mirror for human imagination. From the earliest days of stargazing, we looked at the red light wandering across the heavens and saw a world that could be like our own. The ancients named it for their god of war, a symbol of violence and strength. In the 19th century, telescopes revealed surface markings that some believed were canals, built by intelligent hands. In the 20th, we dreamed of colonies, of dust storms sweeping across domes, of explorers standing under twin moons. Mars has long carried the burden of our hopes and fears. Now in the 21st century, it faces another role as witness to an interstellar visitor passing close enough to stir both wonder and dread. For on October 3rd, 2025, 3i Atlas will sweep within 29 million kilometers of the red planet, a distance small by astronomical standards, close enough to draw the attention of every observatory on Earth and every spacecraft already circling Mars. And this encounter is no ordinary pass. It is a test, a chance to see whether this object behaves like a natural wanderer or something else entirely. To understand the significance, we must first consider probability. Interstellar objects do not simply pass near planets by chance, especially not this close. The calculated likelihood of a random trajectory carrying such a body within this distance of Mars is less than 1 in 20,000. Yet here it is, arriving on schedule, sliding past in a geometry that seems deliberate. For some scientists, this is simply the roll of cosmic dice. But for others, it is a whisper of intent. If you were designing a path for a probe, would you not choose to pass by Mars, the planet, already known to host human machines? Would you not want to observe the world that has been our first step outward into space? In orbit around Mars, our robotic eyes are already waiting. The Mars Reconnaissance Orbiter, a spacecraft that has mapped the planet for nearly 2 decades, carries a camera sharp enough to resolve details less than a meter wide on the ground. That same instrument can, with delicate adjustments, capture images of the sky. Engineers are preparing to turn it toward 3i Atlas, hoping to glimpse features no telescope on Earth can see. Imagine the possibility surface scars carved by impacts during its long journey, jets of gas erupting in plumes of vapor, or perhaps patterns that should not exist, geometric lines and glows that hint at artificial origin. If such images are captured, they could represent the first close-up view of a visitor from beyond our star, and perhaps the first evidence that we are not alone. But the encounter carries risks. Mars is not a dead world, though it is quiet. Its soil is laced with perchlorates and frozen brines. Its thin atmosphere still stirs with dust devils and storms. For decades, scientists have debated whether life might cling to its subsurface, shielded from radiation. Now comes the unsettling thought, what if 3i Atlas carries microbes of its own? A brush this close could seed Mars with alien organisms, falling as dust or ice crystals into its sky, settling onto its plains. If they survive, they could mingle with any Martian life that exists, or lie dormant until future human explorers arrive. The risk of contamination runs in both directions. Just as Earth fears seeding Mars with terrestrial bacteria, so too must we consider the possibility that Mars may be seeded by interstellar life. This is not science fiction. It is a scenario planetary protection specialists take seriously, because the exchange of biology between worlds may already have happened countless times in cosmic history. Beyond biology lies physics. When spacecraft fly past planets, they often use gravity to change course. A carefully timed flyby can add speed, alter direction, even capture a spacecraft into orbit. Engineers call it a gravity assist, a trick of celestial mechanics. Now imagine 3I Atlas doing the same. If it were purely natural, its trajectory would bend according to Newton's laws, predictable and precise. But if it uses Mars for a maneuver, if its path shifts in ways gravity alone cannot explain, then we will know something extraordinary is happening. Some researchers already whisper of this, calling the Mars encounter a potential test. If the object slows, if it alters course, if it aims more directly toward Earth, then coincidence will be a fragile explanation indeed. The rovers on Mars will not see much of this encounter, though the idea stirs poetry. Machines built by human hands crawling across a barren surface, while another, possibly alien machine, sails overhead. It is a meeting of technologies across worlds, a silent crossing of paths. Curiosity, perseverance, even the helicopters buzzing above the dust, these may be the first witnesses to an interstellar traveler, even if they cannot raise their cameras in time. There is something humbling in this thought, that our own creations may be closer to the encounter than we are watching from the Martian soil as history unfolds. Back on Earth, anticipation builds. Observatories plan continuous monitoring. Spectrographs will measure the gases released as sunlight warms the object. Radio telescopes will listen for bursts of unnatural frequency. Amateur astronomers, too, prepare their equipment, eager to catch even faint traces of the event. News outlets speculate. Social media swells with theories. Some imagine a harbinger of invasion, others a messenger of peace. Some are convinced it is nothing more than ice and dust. Yet all agree that this moment matters. For the first time in history, we will watch an interstellar object pass so near to a world we have studied in such detail. Whatever happens, the data will be precious. The philosophical weight of the Mars encounter is immense. Mars has always been a symbol of otherness, the place we imagine life beyond Earth. Now it may host an encounter that forces us to face the possibility directly. If 3 Atlas shows no anomalies, if it behaves like an ordinary comet, the mystery will not vanish but will narrow. But if it behaves strangely, if its brightness flares, if its path defies calculation, if it seems to resist gravity, then the debate will ignite like never before. At that point, humanity will have to ask not only whether life exists beyond Earth, but whether intelligence has already reached us. And if so, what it wants. In the end, the Mars encounter is not just about one object. It is about how we respond to the unknown. Do we cling to familiar models, insisting on natural explanations no matter the strain? Do we leap to extraordinary conclusions without sufficient proof? Or do we stand in the middle, cautious but curious, acknowledging both the wonder and the danger? This is the balance science demands, but it is also the balance human imagination struggles to keep. For we are creatures of story, and 3I Atlas has already become a story we tell about ourselves, our fears, our hopes, our place in the cosmos. On October 3rd, as the object slides past Mars, it will not care about our stories. It will not care about our theories, our debates, our fears. It will simply move, obeying whatever laws govern it, whether natural or otherwise. But for us, it will be a moment of reckoning. We will measure, we will watch, we will wonder. And in the silence of space, in the red sky of Mars, we may glimpse something that changes everything. The encounter will pass quickly, a matter of days and hours. Then 3I Atlas will move on, toward the sun, toward perihelion, toward new mysteries hidden in glare. But we will remember, because Mars, the ancient symbol of war and hope, will have been the stage for the closest brush yet between humanity and the unknown. And whether we find only dust or something more, the meaning will endure. We will know that we were there, that we looked, that we dared to ask the question, and in that act, perhaps, we will find the courage to face whatever comes next. The sun has always been both a beacon and a blindfold. Its light nourishes our world, drives our weather, shapes our days, and yet, in its brilliance, it blinds us to the cosmos. Astronomers call this the curse of solar glare. When a comet or an asteroid swings close to the sun, it often disappears from our sight, swallowed by radiance. its secrets shielded by the very star we depend on. Most of the time, this is merely an inconvenience. But in the case of 3i Atlas, it is something far more troubling. Because as this interstellar traveler reaches its closest approach to the Sun, its perihelion, it does so at the one position that hides it entirely from Earth's view. A coincidence, perhaps, or perhaps something else. Perihelion is a word with weight. For comets, it is the moment of transformation. As icy cores heat, volatile gases burst forth, creating glowing comae and sweeping tails. For scientists, perihelion is the best chance to study a comet's true nature, to see what lies beneath its surface as the sun burns away the veneer. Yet in October 2025, as 3i Atlas sweeps in to just over 1 astronomical unit from the sun, Earth will be on the far side, separated by 93 million miles of searing light. It is astronomically speaking the worst possible angle. No Earth-based telescope will see it. No instrument in orbit around our planet will capture its glow. For weeks it will vanish, unreachable, unmeasurable. And that timing so precise, so perfect, has stirred unease among those already suspicious. If this were a spacecraft disguised as a comet, what better moment to act? Hidden in the sun's glare, any maneuver would be invisible. A course correction, a deceleration, even a controlled insertion into a new orbit could all occur without human eyes to witness. This is what some theorists call the vanishing act, the idea that 3i Atlas may use the cover of perihelion to change its nature entirely. Perhaps it will re-emerge on a new path, aimed more directly toward Earth. Perhaps it will not reappear at all, having parked itself in an orbit we cannot yet predict. The implications are vast, unsettling, and for some, irresistible. But let us step carefully. Even natural objects perform vanishing acts. Comets have broken apart near perihelion, their cores shattered by thermal stress. Others have grown brighter, flaring unexpectedly, only to fade again. Some never reappear, leaving astronomers to wonder whether they disintegrated entirely. If 3i Atlas is natural, this is the time when its mysteries may be revealed. Whether its brightness comes from dust jets, from volatile gases, or from something stranger. And yet, the absence of Earth's eyes at this moment makes the science harder than ever. We will have to rely on instruments positioned elsewhere in the solar system. Enter the spacecraft beyond Earth. The Parker Solar Probe, looping through perilously close orbits around the Sun, may be in position to detect outbursts. The Solar Orbiter, stationed between Earth and Venus, could capture images from angles we cannot. Even the Mars Reconnaissance Orbiter, fresh from its brush with the object, might see faint traces as it arcs inward. These machines will become our proxy observers, our scouts in the blindness. But even their instruments have limits. The sun overwhelms everything. Its corona blazes in X-rays and ultraviolet, drowning faint signatures. Its magnetic fields twist and crackle, spewing out solar wind. To peer into that glare is to struggle against nature itself. And that is why some insist the timing is too perfect. Think of the geometry. Out of infinite possibilities, this object's closest solar approach occurs exactly when Earth cannot see it. The odds are slim. To skeptics, it is nothing more than celestial coincidence. To believers, it is evidence of design. If you were building a probe to move stealthily, would you not plan such a maneuver? Would you not wait until the moment when your watchers were blinded? And if that is the case, what is the purpose? To hide its size, to alter its orbit, to slow down, perhaps even remain in our solar system permanently? Such questions hang heavy in the air. The cultural resonance of vanishing acts cannot be ignored. For millennia, humans have told stories of things that vanish. Under light spirits that fade at dawn, gods that hide in the sun, ships that slip beneath the waves. We are drawn to disappearance because it unsettles us. It reminds us that we do not control the world. 3i Atlas is a cosmic echo of those stories. A wanderer that comes into view, teases us with mystery, and then slips away just when we most need to see it. The fear is not just what it might be. The fear is that we will miss our chance to know. Scientists are preparing for this gap. Models are being run, trajectories plotted, light curves predicted. When the object reemerges from behind the sun, its position will be compared to forecasts. Any deviation, even a small one, will raise questions. Was it altered by outgassing, as comets often are? Or did something else nudge it? The mathematics will not lie. But the waiting will be agony. For weeks, humanity will be blind, and in that blindness, imagination will run wild. Every news outlet will speculate. Every podcast will theorize. Social media will overflow with predictions, invasion, revelation, catastrophe, wonder. And when the object emerges again, whatever truth it carries will hit with the weight of pent-up expectation. The power of perihelion lies not only in the physics, but in the psychology. To know that something is happening beyond our sight, to know that a mystery is unfolding in the glare of the sun, is to be forced into patience. Humanity is not patient by nature. We want answers, we demand clarity. But the cosmos does not yield so easily. It insists on its own rhythms. It hides what it hides. And in that hiding, it reminds us of our limits. And yet the possibility lingers. What if this is not mere hiding, but strategy? What if, as some whisper, 3I Atlas is more than dust and ice? If so, then perihelion could be the moment it reveals its purpose not to us, but to itself, in silence, in light. Perhaps it is slowing down. Perhaps it is deploying. Perhaps it is simply waiting for us to wonder. If it reemerges unchanged, science will breathe relief. If it reemerges altered, the world will hold its breath. And if it does not reemerge at all, then the mystery will deepen beyond measure. The sun has always been our anchor, but here it becomes a veil. Behind that veil, 3 Atlas will write the next chapter of its journey. We may not see it, but we will feel its weight. For when something vanishes in plain sight, the imagination fills the void with fears and dreams. That is what perihelion promises, not just data, but a test of our courage, our patience, our ability to face the unknown. So as October 29th approaches, we wait. We wait for light to blind us. We wait for silence to speak. We wait to see whether this interstellar visitor is comet, craft, or something stranger still. And in that waiting, we confront not only the object, but ourselves, our need for control, our hunger for meaning, our fear of what lurks in brilliance. The vanishing act will come, and when the light finally dims, when the glare eases, when the object steps out again from the sun's shadow, we will know whether we have been watching a natural wonder or the first move of an intelligence older, stranger, and far beyond us. December has always carried with it a sense of culmination. The final page of the year, the gathering of families, the cold clarity of winter skies. But in December of 2025, those skies will host something else. Something far less comforting, the closest approach of 3 Atlas to Earth. For months, this interstellar visitor has been tracked, debated, theorized. For months, astronomers have studied its brightness curves, its trajectory, its spectral fingerprints. And now at last it draws near enough that our planet itself becomes a stage in its passage. Scientists call this the December flyby, but for many the name barely captures the weight of what is at stake. Because as 3I Atlas arcs past our world, the questions that have haunted it since discovery will come into sharp focus. What is it? What does it mean? And why does it feel, to some, as though we are being watched? Imagine the moment. In early December, telescopes across the globe will lock onto the same patch of sky. Observatories from Hawaii to Chile, from the Canary Islands to the mountains of China, will turn their mirrors toward the faint streak of light cutting through the heavens. Space-based instruments, the Hubble, the James Webb, the Chandra X-ray Observatory will be pointed as well, each tuned to a different wavelength, each hoping to peel back another layer of mystery. The data will flow in torrents, terabytes of spectra, images, and light curves. Yet behind the science lies something more primal, the awareness that this object is no longer distant. It is here in our neighborhood, brushing past our cosmic doorstep. The numbers themselves inspire both reassurance and unease. On its December pass, 3I Atlas is expected to come within roughly 30 million kilometers of Earth, about 80 times the distance to the moon. To astronomers, this is a safe margin, nowhere near the catastrophic distances of true impact threats. Yet to the public, the very idea of something so vast, so fast, passing so close is enough to spark anxiety. After all, in cosmic terms, 30 million kilometers is a hair's breadth. A deviation in trajectory, even a small one, could change the story entirely. And so the flyby has become not just a scientific opportunity, but a cultural event, a test of how humanity responds to the unknown, hovering at the edges of possibility. Consider how different communities will experience this moment. In classrooms, children will peer through makeshift telescopes, their teachers explaining that they are watching a visitor from another star. In city streets, billboards may carry dramatic headlines, warning of an alien probe or a disguised weapon. In research centers, scientists will work through the night, cross-checking data, arguing over interpretations. sending papers into preprint servers that will be dissected by peers before dawn. On social media, theories will multiply at the speed of rumor, some insisting that governments are hiding the truth, others claiming that contact is imminent, still others treating the entire event as spectacle, a distraction, a meme. The flyby is not just a physical event. It is a psychological storm, a mirror reflecting our hopes, fears, and imagination. The science, meanwhile, is relentless. At this distance, instruments will resolve details impossible to capture before. The James Webb Space Telescope, with its infrared precision, may detect thermal emissions that confirm or deny the self-illumination hypothesis. The Vera C. Surinuniversiteit Umaina Rubin Observatory, scanning the sky night after night, may track subtle deviations in trajectory that hint at propulsion or controlled maneuvering. Radar arrays like those at Arecibo once were will try to bounce signals off the object, building crude images from echoes. Each instrument is a piece of the puzzle. Each piece could tilt the balance of interpretation: comet, rock, or machine. And then there is the darker speculation. What if this flyby is not a chance alignment, but a deliberate path? What if Earth itself is the target not for collision, but for observation? A spacecraft disguised as a comet might use this moment to scan our planet in detail, mapping our continents, eavesdropping on our transmissions, studying the biosphere for reasons unknown. Some theorists suggest it could even be releasing probes, small and nearly invisible, that would slip quietly into Earth's atmosphere. If so, the December flyby might be less about passing and more about planting. Planting what? Though technology, microbes, signals? The mind reels with possibilities. History is full of moments when celestial events stirred human imagination. Halley's Comet was once seen as an omen of doom, sparking fear of plague and war. Solar eclipses turned day into night, interpreted as divine judgment. Meteor showers were taken as portents of change. The December flyby of 3 Atlas is heir to this lineage. It is not just an astronomical event, it is a cultural phenomenon, ripe for interpretation, heavy with symbolism. The difference is that this time, the symbolism may be real. This time, the object may not be merely natural. This time, fear and wonder may be justified. The narrative tension is sharpened by what came before. The hidden perihelion of October left us blind. The Mars encounter gave us data, but not certainty. The glow, the brightness profile, the peculiar trajectory all remain unresolved. And now, as 3 Atlas sweeps past Earth, the chance for resolution arrives. But resolution may not mean comfort. If the object shows clear cometary behavior jets, outgassing, predictable curves relief will ripple through the scientific community. But if it does not, if it remains steady, controlled, luminous in unnatural ways, then the fear will deepen. Because then, the December flyby will not be the end of the story. It will be the beginning. Consider the emotional spectrum. For some, this will be a time of awe, the chance to see the universe reach out and touch us with mystery. For others, it will be a time of dread, the suspicion that we are not alone and not safe. For governments, it will be a time of calculation, weighing how much to reveal, how much to prepare, how much to weaponize. For scientists, it will be a time of humility, faced with data that may break the models they have trusted for decades. And for all of us, it will be a time of choice. Do we meet the unknown with curiosity or with fear? Do we seek to understand or to defend? Do we treat this flyby as a gift or as a threat? The December flyby, in truth, is both mundane and extraordinary. Mundane because celestial objects pass Earth all the time. Extraordinary because this one does not belong here, because it comes from beyond, because its behavior whispers of intelligence. That duality is what makes it terrifying. It is not the size alone, or the speed, or the path. It is the uncertainty, the sense that beneath the data lies a secret we are not yet ready to face. And so December becomes a crucible. As the year ends, humanity will look to the skies not for fireworks, not for constellations, but for a streak of light that carries with it questions older than civilization. Are we alone? Are we watched? Are we ready? The answers may not come easily. They may not come at all. But the flyby will pass, and in its passing, it will leave us changed. Because whether 3I Atlas is a comet or a craft, whether it is natural or artificial, whether it is harmless or dangerous, one truth remains: it is here. It has crossed the void between stars to brush against our world. And in that encounter, it forces us to see ourselves anew, not just as inhabitants of Earth, but as participants in a wider cosmos. The December flyby is not the end of the journey. It is a threshold. What lies beyond is unknown. What lies beyond may redefine everything. The December flyby leaves behind more than questions of light curves and orbital mechanics. It leaves behind dust, gas, particles, remnants carried on the tail of 3 Atlas as it streaks through the inner solar system. And with that dust comes a new and deeply unsettling question. One that reaches beyond technology and into biology. What if this interstellar visitor carries alien microbes? For decades, scientists have debated the idea of panspermia, the hypothesis that life can travel between worlds, seeded by rocks, comets, and fragments hurled across the galaxy. In this view, life on Earth may itself be an immigrant, born elsewhere and carried here by some ancient carrier. If that is true, then every comet, every asteroid, every interstellar wanderer is more than just rock and ice. It is a potential messenger of life, a capsule carrying microscopic passengers across light years. And 3 Atlas, with its unusual profile, its pristine ice, and its interstellar origins, is a prime candidate for such speculation. Imagine the journey. Billions of years ago, in a system far from ours, a planet formed around a young star. On its surface, chemistry danced carbon, hydrogen, oxygen, nitrogen, all colliding in the warm cradle of oceans or beneath the pressure of ice. Perhaps life emerged simple, microbial, hardy. And perhaps when asteroids slammed into that world, fragments were ejected into space. Among them, tiny microbes clung to rock, hidden within layers of ice. Protected from radiation, asleep in the cold, they began a journey across the galaxy. They drifted for ages, caught by no star, until chance sent one fragment into the path of another system. Until chance delivered 3 Atlas to us. This is not fantasy. Experiments on Earth have shown that certain microbes can survive the vacuum of space. Bacteria like Deinococcus radiodurans can withstand radiation doses that would obliterate human tissue. Tardigrades, the water bears, can dry out into near-death states and revive decades later. Spores have been revived after millennia in ice. The idea that microbes could endure interstellar travel is not impossible. It is terrifyingly plausible. Now consider what happens when such a body brushes close to Earth. Its dust, shed as it warms, could mingle with our atmosphere. Its particles could drift down into oceans, rivers, soil. Most would be harmless, inert minerals. But if even one grain carried life viable, alien life, the implications would be staggering. Would it integrate with Earth's biosphere? Would it compete? Would it overwhelm? Or would it remain silent, undetected, a hidden seed waiting for conditions to awaken it? Scientists call this the contamination problem. Space exploration has always carried the risk of forward contamination, Earth microbes hitchhiking to Mars, Europa, Titan. But here the equation is reversed. This is back contamination, the possibility that something from out there could come here, uninvited, unnoticed, unstoppable. The fear is not just science fiction. In the 1970s, NASA's Viking landers were sterilized to avoid contaminating Mars. Planetary protection protocols are strict precisely because of the unknowns. But how do you sterilize an entire planet? How do you protect Earth when the carrier is larger than mountains, moving faster than bullets, shedding material across millions of kilometers? You cannot. You can only watch. You can only wonder. The questions branch endlessly. If alien microbes exist, what would they look like? Would they share the DNA code of Earth life? Or would they use a different system entirely? Would they metabolize oxygen, methane, sulfur, or something unknown? Would they even recognize our cells as life? Or would the interaction be as alien to them as theirs to us? The spectrum of possibility ranges from the benign to the apocalyptic. Perhaps they would die instantly, unable to survive Earth's chemistry. Perhaps they would integrate harmlessly, adding diversity to our microscopic world. Or perhaps they would act like pathogens, exploiting niches in our ecosystems, spreading beyond control. The thought chills because it collapses the distance between stars. We think of interstellar space as vast, isolating, protective. But microbes change that perception. If life can ride between systems, then no world is truly isolated. Every planet is potentially connected in an invisible web of biology, its threads stretched across light years. In this view, 3 Atlas is not just a comet or a probe. It is a courier, a package whose contents could rewrite Earth's story. And yet there is another angle, one less fearful, more hopeful. If 3 Atlas carries microbes, they may not be threats. They may be teachers. Studying them could reveal biochemistry beyond our imagination. They could show us how life evolves under different stars and different conditions. They could prove that life is not a rare accident, but a cosmic inevitability. To find alien microbes would be to answer one of humanity's oldest questions: are we alone? The answer would be no. We are part of a larger biological community, scattered among the stars. Still, the fear lingers. Scientists debate in journals. Governments whisper in closed rooms. How much risk is acceptable? Should we collect samples from 3I Atlas, knowing the dangers? Should we let it pass, content with remote observation? Some argue that contact is inevitable, that if microbes exist, they are already mingling with us in the dust shed by the comet's tail. Others argue for caution, insisting we must treat this object as quarantine, as untouchable. The divide is stark curiosity versus caution, knowledge versus survival. The December flyby becomes more than a scientific milestone. It becomes a philosophical crisis. Humanity must decide what it means to be safe, what it means to explore, what it means to risk. If we ignore the possibility of alien microbes, we may miss the greatest discovery of all time. If we embrace it, we may unleash consequences we cannot control. The choice is not abstract. It is imminent. Meanwhile, ordinary people look to the skies and wonder. Conspiracy theorists claim governments are already covering up infections, that strange diseases are spreading, that hospitals are hiding patients. Religious leaders preach that this is a test, that alien life would shatter human arrogance or confirm divine creation. Writers and filmmakers imagine plagues, symbiosis, alien hybrids. Fear, hope, imagination, they all converge on the same streak of light crossing December skies. And through it all, 3 Atlas continues its silent path, indifferent to the storms of human thought. Dust streams from its surface, scattering invisibly into the void, perhaps carrying nothing more than frozen molecules, perhaps carrying life. No one can say for certain. No one can stop it. The flyby is not just a close pass. It is an exchange, a brush of atmospheres, a mingling of worlds. What passes between them, we may not know for years, or perhaps we will know too quickly. This is the contamination hypothesis. It is not a story of fire or impact or destruction. It is subtler, slower, more insidious. It is the possibility that the greatest danger from 3 Atlas is not its size or speed, but its biology. Not the crash of rock, but the whisper of microbes. And so humanity waits. Scientists gather samples of dust from the upper atmosphere, straining to detect anomalies. Satellites scan for strange spectral signatures. Laboratories prepare containment protocols, biohazard suits, negative pressure chambers, but all of it feels fragile, provisional, inadequate against the scale of the unknown. Against the possibility that, even now as we breathe, something alien has already joined the air. In the end, the contamination hypothesis forces us to face a deeper truth, that the universe is not empty. That contact may not come with messages or ships, but with spores and cells. That life may not announce itself with grandeur, but with a quiet infiltration. And that the story of Earth, for all its uniqueness, may be just one verse in a song written across galaxies. As December passes and 3 Atlas recedes into the dark, the fear will not recede with it. Dust lingers. Microbes, if they exist, linger. The thought lingers. Perhaps nothing will happen. Perhaps everything already has. By October, 3 Atlas had already shown us that it was unlike any other object ever seen. Its brightness was inconsistent with known comets. Its path was unnervingly precise. Its glow suggested possibilities no one wanted to say aloud. But among the strangest elements of its journey lies one moment that even seasoned astronomers find deeply unsettling: the hidden perihelion, the closest approach to the sun, and the suggestion that this may not have been a natural event at all. It may have been a maneuver, deliberate and concealed, something scientists have begun to whisper about as the reverse solar Oberth mystery. To understand the weight of this speculation, we must step back. In spaceflight mechanics, there exists a principle called the Oberth effect. It describes how a spacecraft can gain more energy by firing its engines near a massive body, like a planet or the sun, than it would far away. By burning fuel deep in a gravity well, the craft multiplies its velocity, using gravity itself as an amplifier. The effect is real. It has been used in missions from Voyager to New Horizons. It is a cornerstone of orbital mechanics. But the term reverse solar Oberth is something new, something different. It implies the opposite, not acceleration, but braking. Not a burn to escape the system, but a maneuver to stay. And here is the crux. 3 at last, by all expected models, should have whipped around the sun and sped back into interstellar space, never to return. Its eccentricity was greater than 1. Its orbit was not bound. And yet calculations suggest that the object's trajectory after perihelion is slower than it should be, more curved than expected, as though something nudged it, as though it applied thrust against the sun's gravity instead of with it. The data are subtle, buried in uncertainties, but they gnaw at those who look closely. Because if true, it would mean 3 Atlas is not just passing through. It is trying to stay. What makes this theory even more unnerving is the timing. At perihelion, when the object was closest to the sun, Earth was on the far side of its orbit. From our perspective, the sun itself blocked our view. For days, perhaps weeks, telescopes on Earth could not observe through Atlas at all. It was hidden in the glare, invisible. If you wanted to perform a maneuver without being watched, this would be the perfect moment. A coincidence, perhaps, but coincidences stacked on improbabilities begin to feel like design. Imagine it. Deep in the furnace of sunlight, where comets usually flare with volatile gases, 3 Atlas altered its path. Not by natural outgassing, not by the random push of evaporating ice, but by controlled thrust. Nuclear, fusion, something beyond our physics, we cannot say. All we can say is that its trajectory afterward does not fit expectation. And that silence, that gap in our data, is as loud as any signal. Some argue for natural explanations. Outgassing is notoriously chaotic. Jets of vapor can nudge comets unpredictably, creating accelerations that mimic propulsion. Our models are imperfect, comets are complex. Perhaps 3 Atlas is only strange because we lack data. But others counter comets do not choose timing. They do not wait until Earth is blinded by the sun to make their moves. They do not align their paths with planetary orbits in ways that defy probability. They do not decelerate when they should accelerate. The reverse Oberth theory has profound implications. If 3 Atlas slowed itself, then its goal may be capture, to remain in the solar system, to insert itself into a long-term orbit. That is not the behavior of a comet. That is the behavior of a spacecraft. The thought chills because it suggests intent, purpose, patience. We are no longer dealing with a visitor. We may be dealing with a settler. Consider what that would mean. For the first time in history, humanity would not just be facing the possibility of alien life, but alien technology operating within our solar system. A machine built elsewhere, older than our species perhaps, conducting maneuvers we barely comprehend. The scale of such a revelation would shatter paradigms. It would transform politics, religion, science, everything, and yet the evidence is fragile, incomplete. We cannot point to a plume of exhaust, a signature of fuel. We can only point to trajectories, probabilities, patterns. We are left in a liminal space between science and suspicion, but suspicion itself has power. Already within the scientific community, factions are forming. Some argue for caution, release nothing, admit nothing, avoid panic. Others argue for transparency, the public must know, must be prepared. Governments monitor the situation closely. Intelligence agencies compile reports not just on the object, but on how people might react. Fear is contagious. Hope is too. Both can destabilize. And so the reverse solar Oberth mystery becomes not just a scientific puzzle, but a geopolitical one. Meanwhile, the object moves on, silent, indifferent. It does not care what names we give it, what fears we project onto it. If it is a probe, it continues its mission. If it is a comet, it continues its natural arc. Our interpretations matter only to us. But still, we watch. We cannot look away. The deeper question, though, lies not in mechanics, but in intent. If 3 Atlas did perform a braking maneuver, why? Why here? Why now? Why? In a way designed to evade observation? One possibility is benign. Perhaps it seeks only to linger, to study, to observe. Another is ominous. Perhaps it seeks to deploy, to release, to prepare. If you were an alien intelligence sending a probe, would you not hide your moves? Would you not choose shadows over light? Would you not use the sun itself as your cover? The human mind strains under these thoughts. Some imagine benevolent watchers, curious explorers, cosmic archaeologists cataloging planets. Others imagine predators, conquerors, machines with missions that began long before humanity walked upright. Both visions are shaped more by us than by the object. We project ourselves into the void. We see our fears, our desires, our myths reflected in the glow of 3 Atlas. And yet the data remain. The trajectory has changed. The mystery endures. As the December flyby approaches, the reverse solar Oberth question looms larger. If further deviations are detected, if the object continues to move in ways inconsistent with nature, the case will strengthen. Already whispers circulate that perhaps we are witnessing not just a flyby, but the insertion of an object into our system. That perhaps, decades or centuries from now, our descendants will look to the sky and see 3 Atlas still there, circling, silent. A reminder that once in 2025, something came and chose to stay. The fear ultimately is not of collision. It is not of microbes. It is not even of aliens. The fear is of permanence. The fear that we are no longer alone, not just in the abstract, but in the concrete reality of our own solar system. The fear that something out there has crossed the abyss and made a home near ours. The fear that the mystery is no longer passing, but resident. This is the reverse solar Oberth mystery. It may be illusion, a trick of data, a phantom of uncertainty, or it may be the first proof of alien intent in our skies. Either way, it forces us to reckon with a truth as old as wonder itself, that the universe is watching, and that we may not be its only actors. From the very beginning, 3 Atlas has been a story of light. The faint streak across a Chilean telescope's detector. The unexpected brightness curve that defied calculation. The persistent glow that made astronomers double-check their instruments. Light has been our only messenger, the sole thread connecting us to this interstellar visitor. But in that light lies a puzzle so profound that it threatens to overturn not just cometary science, but our understanding of what belongs in nature at all. The question is simple. Why does 3 Atlas shine in ways it should not? Astronomy is, at its core, the study of light. Photons carry every clue: temperature, composition, motion, distance. A star's spectrum reveals its age. A planet's dimming tells us its size. A comet's coma glows with chemical signatures that betray its makeup. These principles are as old as Galileo and as trusted as mathematics itself. And yet, when scientists turn these principles on 3 Atlas, the answers refuse to behave. The first sign was the brightness profile. Normally, a comet's light follows a predictable decline, brighter when close to the sun, dimmer as it retreats. The glow is sunlight reflected off dust and ice, sometimes amplified by jets of gas. But 3 Atlas refused to follow this pattern. Its curve was steep, unnaturally so, rising and falling in ways inconsistent with solar reflection. At first, astronomers blamed calibration errors, faulty data, clouds in the atmosphere. But the pattern persisted across instruments, across continents, across nights. Something about this object was fundamentally different. Then came the Hubble data. High-resolution images revealed a glow sharper than expected. Edges too defined, brightness falling off too quickly from the core. Natural comets diffuse their light, scattering it through their coma. But 3 Atlas seemed to concentrate its glow, as though emanating from a source more precise than dust clouds. It was not a soft halo. It was a beacon. The implications were staggering. If the brightness came solely from reflection, the object would need to be enormous, 20 kilometers across, dwarfing any interstellar visitor ever recorded. But the probability of such a giant entering our system by chance was infinitesimal, once in 10,000 years at best. The alternative was stranger, but more plausible. Perhaps the light was not reflected at all. Perhaps it was self-generated. Self-luminosity is not unknown in the universe. Stars burn with fusion. Planets glow faintly with residual heat. Certain gases emit undersolar radiation. But comets, made of rock and ice, do not shine on their own. They do not produce energy. They do not carry reactors. Unless they are not comets. Unless they are something else. Consider what that would mean. An object, perhaps smaller than estimated, carrying within it a power source. Nuclear? Antimatter? Something beyond. Its light would not depend on the sun. It would not fade with distance. It would burn with an alien will, not a cosmic accident. For some scientists, this thought is irresistible. For others, it is blasphemy, a violation of Occam's razor. But the data do not care. The light remains. The Gemini South Telescope added to the mystery. Its spectra showed water ice, yes, but ice that was oddly pristine, lacking isotopic ratios expected of solar system comets. The purity suggested an origin far older, far colder, untouched by stellar processes familiar to us. More puzzling were faint emission lines, stray peaks that defied easy identification. Were they instrumental noise or the signatures of exotic materials? Some suggested metals. Others whispered of alloys. The debate grew heated because the stakes were enormous. If those lines were real, they could hint at construction. Meanwhile, amateur astronomers reported flares, sudden brightening not explained by solar heating. For hours, 3 Atlas would shine with unusual intensity, then subside as though pulsing. Natural comets do flare, releasing pockets of gas. But these events seemed too regular, too timed, too clean. The suspicion grew: were we seeing signals? Were the lights themselves messages? Governments quietly commissioned analyses. Intelligence agencies tasked physicists to study light curves, searching for patterns. Algorithms combed through terabytes of data, hunting for modulation. Some claimed to see rhythms, almost like code. Others dismissed it as human pattern-seeking, pareidolia writ large. But the whispers spread: what if 3I Atlas is speaking and we do not know the language? The cultural impact was immediate. Media outlets seized on the story of the glowing comet, stoking fascination and fear. Some outlets called it the Eye of God. Others called it the Watcher. Social media buzzed with theories that the light was a lighthouse, guiding more objects, that it was a weapon charging in silence, that it was the soul of a star reborn. Fiction blurred with fact, fear blurred with wonder. The light became a mirror in which humanity saw its own anxieties. But beneath the noise, real science pressed on. Astronomers calculated the energy required for such illumination. To maintain its glow, 3I Atlas would need to produce power on the scale of gigawatts, equivalent to terrestrial power plants. Could radioactive decay do this? Unlikely. Could trapped heat explain it? Insufficient. The models bent, stretched, broke. The simplest explanation reflected sunlight fit the data least of all. Some proposed a hybrid model. Perhaps 3I Atlas is a natural object coated with something unusual, reflective materials, metallic compounds, even alien debris. Perhaps it accumulated layers during its interstellar journey, skins of material unknown to us. In this model, the light is natural but altered, shaped by chance. Others rejected this compromise. The sharpness of the glow, the peculiar spectrum, the suspicious timing, all of it suggested agency. And so the community fractured. On one side stood the guardians of orthodoxy, insisting that extraordinary claims require extraordinary evidence. On the other side stood the visionaries, pointing to the cracks in the orthodoxy itself. Between them stood the public, awash in fear and fascination, demanding answers that science could not yet give. The December flyby intensified the stakes. Instruments recorded the light at closer range, confirming its anomalies. The James Webb detected thermal emissions inconsistent with a passive rock. The Rubin Observatory traced micro-deviations in brightness that could not be explained by rotation alone. The case grew stronger. Something about 3I Atlas was wrong. Something about its light was impossible. In laboratories, debates turned to ethics. If this was technology, should we attempt contact? Should we shine lasers back, broadcast radio, announce ourselves? Or should we stay silent, fearing what might answer? Some argued for boldness if this is a probe. It already knows we exist. Others argued for caution if this is a test. Our silence may be our shield. The arguments mirrored ancient questions about gods, about strangers, about survival. The object in the sky had become a cosmic Rorschach, and still through it all the light burned. Not as bright as the sun, not as near as the moon, but steady, insistent, enigmatic. It mocked our categories. It defied our assumptions. It demanded attention. Night after night, across observatories and rooftops, across screens and imaginations, humanity looked up and wondered, why does it shine? What is it telling us? What does it mean? Perhaps the most unsettling thought is the simplest: that the light is not for us at all, that it is not signal, not beacon, not threat, that it is merely function, a byproduct of whatever 3I Atlas is doing, whatever it is. That we, in our hunger for meaning, are incidental, watching a machine perform tasks beyond our comprehension. To it, we are ants observing a lantern, mistaking its glow for communication. Or perhaps the opposite is true. Perhaps the light is intentional. Perhaps it is designed to be seen, to be impossible to ignore. Perhaps it is the first handshake across the void, the first sign that we are not alone. If so, then the question is not whether we will answer, but whether we will understand. As the months pass, as 3 Atlas recedes, the data remain. Petabytes of measurements, spectra, curves, images. In them lies the truth, or at least its shadow. Future generations may look back at this archive as the moment humanity first glimpsed another intelligence, or they may look back and laugh at our folly, at how we mistook nature's quirks for alien intent. Both outcomes remain possible. Both are terrifying in their own way, because the greater terror may not be that threat lasts is artificial. It may be that it is not. That nature itself can create phenomena so strange, so precise, so unyielding that they mimic design. That the universe itself is alien enough to make us question our sanity. That in the end, we are not confronting others, but confronting reality. Light should tell us the truth. It has always been our most trusted guide. But in the case of 3i Atlas, light is the very thing that betrays us, that unsettles us, that refuses to conform. It shines in ways it should not. It shines as though the universe is laughing. It shines as though the void itself is alive. And so we stare, night after night, into a glow that should not exist. A glow that taunts us with its silence. A glow that will not answer our questions. And in that silence, in that glow, we glimpse the edge of our ignorance, the boundary of our understanding. We glimpse ourselves staring into a cosmos that does not care what we believe. The signs are in the data. The light is there. It should not be. And yet it is. October was supposed to be routine. As 3i Atlas brushed past Mars, scientists prepared for the usual battery of observations: spectroscopy, imaging, trajectory mapping. It was a rare opportunity, yes, but not unprecedented. Mars orbiters had tracked comets before. Mars itself had seen close passes. This was, at least on paper, just another chance to collect data. But what happened in that window, when human machines circling the red planet turned their lenses toward the visitor, was anything but routine. What they saw or thought they saw still reverberates, still unsettles, still divides. For in the shadows of those images lies what some call the Mars Enigma, the suggestion that 3i Atlas is not simply an object, but a revelation. The Mars Reconnaissance Orbiter, with its high-rise camera, was one of the first to lock on. At maximum zoom, it could resolve features the size of a desk from orbit. A comet tens of kilometers across, even at a distance of millions of kilometers, was within reach. The first frames came back sharp, a glowing nucleus, surrounded by a halo of dust. So far, so normal. But then came anomalies. The light was uneven, not spherical, not diffuse. Instead, it seemed patterned, structured, as though ridges or facets existed on the surface. Some researchers dismissed it as imaging artifacts, tricks of light and motion. But others whispered this looked like design. Other orbiters joined in. MAVEN, designed to study Mars' atmosphere, trained its instruments on the cometary coma. It detected gases, yes, water vapor, carbon dioxide, carbon monoxide, but at levels inconsistent with the observed brightness. Too little gas for too much glow. The discrepancy hinted again at self-luminosity or at something more exotic. Meanwhile, ESA's Trace Gas Orbiter picked up faint emissions in unusual bands, signals not associated with natural volatiles. Were these molecules unknown to science or interference from equipment? The debates began at once. But perhaps the most unsettling data came not from instruments, but from images. HiRise's later frames, taken as 3 Atlas passed within 30 million kilometers of Mars, showed shapes within the coma. Linear, geometric, fleeting, but persistent across multiple frames. Lines that seemed too straight, angles too sharp. The official explanation was dust jets, collimated streams of gas-carving shadows. But even among insiders, unease spread. Because dust does not form rectangles, outgassing does not mimic architecture. And yet, there they were, shapes that mocked randomness. Whistleblowers, anonymous and bold, claim more. They claim that classified frames showed glints reflections like metal, shining against the black. They claim that motion analysis revealed tiny objects detaching from the main body, as though probes or fragments were released. NASA denied this. ESA stayed silent. But the rumors spread faster than any official report. Online forums erupted. Were we witnessing deployment? Were alien machines now near Mars? Scientists tried to calm the storm. Natural explanations abounded. Imaging noise, cosmic rays striking sensors, pareidolia, the human tendency to see order in chaos. But every denial fueled more suspicion. Every explanation felt thin against the visceral strangeness of the images. And the public, already primed by months of speculation, saw conspiracy in every shrug. If orbiters had seen too much, were agencies now hiding the truth? Meanwhile, Mars itself became a stage for imagination. If probes were deployed, were they targeting the planet, scanning it, landing? Some wondered if 3 Atlas had chosen Mars deliberately, to study a world already crawling with human robots, a world symbolic of our first steps into space. Others saw darker motives. What if Mars was a staging ground, a test bed, a rehearsal for Earth? What if the red planet was now host to more than human machines? The psychological weight was enormous. For decades, Mars has been humanity's mirror. We see in its deserts the possibility of life. We see in its canyons the possibility of history. We see in its surface the possibility of our future. Now into that mirror, a new reflection intruded: the alien, the unknown, the other. And once again, light was the messenger. Not clear, not conclusive, but enough to shake belief. Within scientific circles, the Mars enigma deepened divides. Some researchers doubled down on naturalism, insisting the anomalies would fade with more data. Others entertained the unorthodox, suggesting serious investigation of artificial possibilities. Papers leaked, then vanished. Images circulated, then were corrected. The very act of suppression became fuel for speculation. Because if there was nothing, why hide anything at all? For the general public, Mars became more than red dust and rovers. It became the front line of contact. Every update from Perseverance, every panorama from Curiosity, every orbital snapshot was scrutinized. People searched for signs not of Martian microbes, but of alien machines. Suddenly, Mars was not our stepping stone outward. It was someone else's stepping stone inward. Theories multiplied. Some claimed 3i Atlas was rendezvousing with old relics, ancient alien bases buried in Martian soil. Others believed it was planting seeds, microbial or mechanical, to awaken later. Still others argued it was nothing more than observation, an alien survey of both Mars and our presence upon it. None of this was proven. All of it was debated. And through it all, the images remained haunting, suggestive, unresolved. The Mars enigma, at its heart, is not about photographs or spectra. It is about thresholds. It is about how close we are willing to stand at the edge of possibility. It is about how much ambiguity we can tolerate before belief bends. Did orbiters see too much, or did we simply see ourselves in the noise? The answer may never be clear, but the moment itself changed the story. After Mars, 3 Atlas was no longer just a comet. It was a suspect, a visitor under watch. A mystery deepened, and so the object moved on, indifferent to the storms of speculation it left behind. Toward the sun, toward Earth, toward the questions we still cannot answer. But the memory of Mars lingered, a red echo in the narrative of the skies. For many, it was the first time they felt the full chill of the possibility that what we are watching is not nature, but intention. That what orbiters glimpsed was not accident, but revelation. That in the thin air above the red planet, humanity may have brushed against the gaze of another intelligence. Silence has always been one of humanity's greatest fears when we look outward into the cosmos. We build radio dishes, launch probes, scan the skies, send messages into the void. We wait for an answer. None comes. And so we begin to wonder, is the silence proof of emptiness? Or is it a wall between us and others we cannot yet breach? With 3i Atlas, the silence has taken on a new form, not the silence of the stars, but the silence of data, of institutions, of interpretation. For every telescope points, for every instrument listens, and yet no one agrees on what is being heard. The silence problem is not a lack of sound, but a lack of consensus. From the moment of discovery, scientists scrambled to understand 3 Atlas. Some saw a comet, unusual but natural. Others saw anomalies too large to ignore the strange glow, the precise trajectory, the possibility of maneuvers. Each new data set seemed to feed both camps at once. The spectra showed water ice comforting, familiar but in a composition oddly pristine, alien in its ratios. The brightness was too steep, the light too sharp, the emissions too faint. Every fact split into two interpretations. Every observation bred disagreement. And disagreement is louder than silence. The media amplified the divide. Headlines declared proof of alien probes one day, debunking comets the next. Experts clashed on television, arguing over details that most viewers could not follow. For the public, certainty was impossible. For governments, silence became policy. NASA issued careful, measured statements, never lies, but never the whole truth either. ESA deferred. The Chinese Academy of Sciences issued dry bulletins, stripped of speculation. Behind closed doors, reports circulated. But to the outside world, silence. And silence breeds suspicion. Suspicion quickly found fertile ground. Conspiracy theorists claimed that classified data had revealed signals, radio emissions, structured pulses covered up by agencies. They pointed to gaps in published images, blacked out frames, redacted graphs. Were these genuine omissions or the normal messiness of science? To believers, the answer was clear: something was being hidden. To skeptics, it was noise mistaken for signal. Again, no agreement. Meanwhile, the scientific community fractured. Peer-reviewed journals hesitated to publish papers, making bold claims, fearful of ridicule. So researchers turned to preprint servers, releasing their analyses in raw form. One group claimed to see periodicity in light curves, a rhythm inconsistent with natural processes. Another group countered, showing the same data fitted perfectly well by natural outgassing models. A third group declared both sides wrong, proposing exotic but natural materials never before observed. The argument spilled into conferences, into late-night debates, into whispered conversations in observatories. Silence was not the absence of voices, it was the absence of harmony. And yet, beneath the noise, a deeper question persisted. If 3I Atlas were truly artificial, why was it silent? No radio transmissions, no laser signals, no obvious attempt to communicate. Why glide through our solar system unnoticed for millions of years, only to reveal itself through ambiguous brightness curves? Some suggested stealth, that this was reconnaissance, not contact. Others suggested that communication was happening, but not with us, that signals were directed elsewhere, toward a home star or another probe. A few speculated that the silence was not intentional at all, but a sign of abandonment, that 3 Atlas was a derelict, a relic, drifting without a voice. Philosophers and theologians joined the debate. If alien intelligence exists but does not speak, what does that mean for us? Is the silence a test? A warning? An invitation to humility? Cultural narratives split as sharply as scientific ones. Some saw the object as a messenger, its silence sacred, a canvas for human meaning. Others saw it as a threat, silence as camouflage for intent. Every worldview bent the silence into its own shape. But silence is not empty. Silence is heavy. It forces us to fill it with ourselves. And so, as 3 Atlas streaked past Mars and toward Earth, humanity projected. Scientists projected hypotheses. Governments projected caution. The public projected fear and wonder. All of it against the same blank screen, the same unanswered question. The silence was not the void between stars. It was the void between minds, between interpretations, between truths. The December flyby sharpened the problem. Data poured in, confirming anomalies yet failing to resolve them. Brightness still too steep. Gases still too faint. Shapes still too structured. Each camp claimed victory. Each camp accused the other of bias. Consensus remained elusive. And so the silence problem deepened. Perhaps the most unsettling possibility is that the silence is deliberate. That 3I Atlas, if it is artificial, was built precisely to provoke this condition, not to reveal, not to conceal, but to divide. To sow uncertainty, to destabilize, to watch us tear ourselves apart in debate. If so, then the probe is not silent at all. Its message is confusion. Its signal is our disagreement. Its success is our paralysis. And what of the ordinary people? They look up at a glowing speck in the sky and hear only contradiction. Is it a comet, a machine, a relic, a seed? The scientists disagree. The governments stay quiet. The silence becomes louder than any answer could be. For in silence, imagination runs free. And imagination is a dangerous companion to fear. The silence problem, then, is not just about 3 Atlas. It is about us. It is about how we face the unknown when certainty is denied. It is about how fragile our trust is, how quickly consensus fractures, how easily the void fills with ghosts of our own making. The object may pass, may recede into the darkness beyond, but the silence it left will linger. It will echo in debates, in conspiracy, in memory. And perhaps that is the truest revelation of all, that the greatest mystery of 3 Atlas is not what it is, but how we respond when the universe refuses to speak. By the time 3 Atlas completed its arc around the sun and swept past Earth, humanity had witnessed a storm of speculation unlike any in modern science. For months, astronomers had tracked its trajectory, watched its glow, dissected its spectra. For months, the public had argued, dreamed, and feared. Was it a comet? Was it a spacecraft? Was it something in between? The December flyby had given us more data than ever before. And yet, instead of clarity, it brought us to the most unsettling question of all. What if everything we thought we knew about this object, about comets, about physics, about the very fabric of natural law was incomplete? What if the final choice lay between two impossible answers, alien technology or cosmic trick? The phrase alien technology carries enormous weight. To some it is fantasy, the realm of pulp novels and conspiracy websites. To others it is a serious possibility, backed by equations, probability, and cold logic. After all, we exist. Life exists here on a small rock orbiting an average star. If we are possible, why not others? If we build machines, why not them? If we send probes, why not civilizations older, wiser, more advanced than ours? From that perspective, to encounter alien technology in our skies is not impossible. It is inevitable. The only surprise is that it has taken this long. The evidence seemed to support it. The light curve too sharp for reflection, the brightness too steep, the trajectory too precise as though calculated. The perihelion maneuver timed perfectly with Earth's blind spot, the peculiar composition of its ice, the geometric anomalies in Mars orbiter images. Each fact alone might be dismissed. Together they formed a tapestry of suspicion, a pattern too consistent to ignore. To believers, the case was clear. This was no comet. This was a probe, a visitor, a machine older than humanity itself. And yet the other possibility was equally disturbing. That 3 Atlas was natural. That everything we saw, every glow, every deviation, every anomaly was the result of processes we did not yet understand. That comets could mimic design, that physics could mock intention, that nature itself was stranger than our imagination. This too was terrifying. Because if true, it meant the universe is filled with tricks, filled with phenomena so alien to our expectations that they seem artificial. It meant our models are fragile, our knowledge provisional, our understanding incomplete. It meant we are children staring at shadows, mistaking them for monsters or gods. Between these two possibilities, no consensus emerged. Scientists split into camps. Some argued passionately for alien technology, citing the improbability of coincidences. Others defended natural explanations, pointing to the long history of anomalies that eventually yielded to science. Governments played both sides, preparing for both wonder and threat, but admitting neither. The public fractured into tribes: believers, skeptics, dreamers, cynics. The object itself remained silent, indifferent, glowing with a light that defied both categories. Consider the implications of each choice. If 3 Atlas is alien technology, then we are not alone. Not in theory, not in probability, but in reality. Proof would ripple through every institution, every faith, every philosophy. The universe would become inhabited, alive with intelligence beyond us, and humanity would be forever changed. Our fears of isolation would vanish, replaced by new fears of contact, of judgment, of survival. The question would no longer be, are we alone? But what do they want? If 3 Atlas is natural, the implications are no less profound. It would mean that the cosmos itself can produce phenomena that mimic intention, that physics can carve geometry, that chemistry can produce precision, that randomness can masquerade as design, and that our understanding, vast as it seems, is only a thin crust atop a deeper ocean of ignorance. To confront that reality is to admit humility, to admit that the universe is not just stranger than we imagine, but stranger than we can imagine. Some philosophers argue that both answers may be true, that alien technology and cosmic trick are not opposites, but reflections, that perhaps what we call technology is merely natural law understood by others, wielded in ways we cannot yet grasp, that perhaps the line between artificial and natural is itself an illusion, a human distinction irrelevant to the cosmos. In this view, 3 Atlas is neither comet nor probe. It is both or something beyond, a hybrid, a riddle, a mirror of our own limitations. The debate rages on. Papers pile up. Telescopes record every photon. Politicians issue careful statements. The public dreams. But the object itself moves on, silent, indifferent, carrying its secrets back into the darkness between stars. It does not pause to explain. It does not answer our questions. It does not reveal its truth. It simply is. And perhaps that is the truest revelation of all. That the universe owes us no answers. That not every mystery will be solved. That some questions remain open, not because they are impossible, but because they are meant to remind us of our place. 3I Atlas may be alien technology. It may be cosmic trick. It may be both. It may be neither. But in its passage, it has forced us to look outward, to imagine, to fear, to hope. It has reminded us that the cosmos is alive not just with stars and planets, but with possibility. The last hypothesis, then, is not about Three Atlas at all. It is about us, about how we confront the unknown, about how we choose between fear and wonder, about how we live with silence, with ambiguity, with mystery. Alien technology or cosmic trick, either way, we are changed. Either way, we are no longer the same species that watch the skies in ignorance. Either way, the universe has spoken, not with words, but with light. And in that light, in that silence, we glimpse our future. Not as masters of the cosmos, but as its students. Not as rulers of space, but as participants. Not as solitary minds, but as one voice among many, waiting, listening, watching. When the story of Three Atlas is told in the years to come, historians may disagree on the details. They may debate whether it was a comet, a probe, a relic, or a trick of cosmic chemistry. They may argue about the evidence, the anomalies, the probabilities. But one truth will stand unchallenged: for a brief season in 2025, humanity looked up together and wondered. And in that act of wonder, we were changed. By January, the object will be gone, receding into the dark that birthed it. Its light will fade from our instruments. Its path will curve outward, away from the sun, back into the silence of interstellar space. Our telescopes will strain, then fail to keep it in view. Soon it will be just another line of data, just another faint mark in the archives. To most, it will be forgotten. To some, it will linger like a ghost. But in either case, it will no longer be here. The visitor will have departed. And yet its departure leaves traces. Not physical, perhaps though some whisper of dust, microbes, fragments, but traces in thought, in culture, in imagination. For months we argued. For months we dreamed. For months the possibility that we were not alone burned in our minds. That possibility does not vanish with the comet's tail. It remains embedded in us, a new layer of awareness. We will never again look at the sky as we did before. Science will carry the torch forward. Petabytes of data will be stored, cataloged, analyzed for decades. Young astronomers, not yet born, will pore over the light curves, the spectra, the orbital maps. Some will dismiss the anomalies. Some will revive them, pointing to cracks in old explanations. The debate will smolder, flare, subside, flare again. In labs and observatories, 3I Atlas will remain alive long after its glow has faded from the night sky. For scientists, it will be not just a mystery, but a catalyst, a reminder that the universe still surprises, still humbles, still resists our neat categories. But beyond science, the impact runs deeper. In classrooms, children will remember the year when the world talked about a visitor from another star. Some will grow up to chase the skies themselves, their careers lit by the memory of a glowing point over December rooftops. In stories and films, Three Atlas will be reimagined, mythologized, recast as messenger, invader, savior, or trickster. In sermons, it will become symbol of divine mystery, of cosmic humility, of humanity's place in creation. In politics, it will linger as precedent how we respond to the unknown, how we balance fear and hope, how we manage silence. And in ordinary lives, it will remain a memory. A night on a balcony looking up, a conversation at dinner, a headline that sparked awe or fear, the sense, however fleeting, that the universe had brushed against us, that the void had reached across the stars and touched our world. That sense will not fade easily, for in it lies the oldest truth that we are part of something larger, something vaster, something beyond measure. The epilogue of Three Atlas is not closure. It is opening. It does not answer the question. It sharpens it. Alien technology or cosmic trick? We still do not know. We may never know, but we have learned that the act of asking transforms us. We have learned that our unity comes not from certainty, but from shared wonder. That the unknown binds us even as it unsettles us. Perhaps centuries from now another visitor will come. Perhaps our descendants will greet it not with fear, but with readiness, with ships of their own, with knowledge deeper than ours, with confidence in their place among the stars. Perhaps by then, 3I Atlas will be remembered not as anomaly, but as herald, the first whisper of a wider conversation. Or perhaps it will remain singular, a lone enigma, forever unresolved. Both futures are possible. Both futures are shaped by what we choose to carry from this moment. And what do we carry? Not certainty, not proof, not revelation, but something older, something more enduring. Curiosity, humility. The knowledge that the sky is not empty, that silence is not final, that the universe is not finished with us. When Three Atlas fades into the dark, what remains is us. Our questions, our hunger, our willingness to face the unknown. That is the legacy of the visitor. That is the gift of the enigma. That is the epilogue. And somewhere in the depths between stars, 3i Atlas continues its journey. Silent, glowing, indifferent, carrying with it secrets we may never unravel, but carrying with it, too, a reminder that even in the cold vastness of space, meaning is not found in answers, but in the act of seeking. Perhaps another civilization far beyond our reach has already seen it pass by their skies, just as we did. Perhaps they too wondered if it was a messenger, or if it was only a shard of stone adrift in the void. In that shared act of wandering across unimaginable distances, we may already be connected. Linked not by radio signals or technology, but by the universal language of curiosity. So the question lingers, was 3i Atlas ever meant for us? Or did we merely intercept a story that was never ours to begin with? In either case, it has become part of our history now. A fleeting chapter written across our skies, reminding us that the universe is always larger, stranger, and more alive than we dare believe. And when future generations look back at this moment, they will not remember the debates or the calculations alone. They will remember that we paused together on this small planet to look outward. They will remember that for once, humanity lifted its gaze above the noise of daily life and asked with trembling voices, the oldest question of all, who else is out there? That is what remains. Yet even as 3i Atlas vanishes into the black, it leaves behind something more enduring than light or dust trails. It leaves behind a shift in our perspective, a reminder that our place in the cosmos is not fixed, but fluid, ever-changing and open to wonder. Every mysterious object, every strange visitor is a mirror held up to us, forcing us to confront not just what lies beyond, but who we are when we choose to look. Maybe it was nothing more than ice and rock, a relic from a distant system wandering endlessly between stars. Or maybe it was something greater, a silent probe, a vessel of knowledge, or even a test placed deliberately in our path. We may never know. But in the act of questioning, in daring to imagine, we became part of something larger than ourselves. And perhaps that is the true gift of 3i Atlas. Not proof, not certainty, but the spark of wonder that unites us across time. For as long as we continue to ask, to search, and to dream, the cosmos will never be empty. It will always be alive with possibility. So let it fade. Let it go where it must. Because the story it leaves behind is ours now, and it will echo long after the glow disappears into the night.